the time has come to put it all together. All right, let's walk through the next, how many more examples do we have? 3 examples. All right, we're going to do it all. We're going to set up our null and alternative. We're going to note what kind of test it is, use the online calculator to pull that information, make a decision, write a conclusion. All right, we're doing it all. Here, Jeffrey is an 8-year-old. And he established a mean time of 16.43 seconds for swimming the 25-yard freestyle with a standard deviation of 0.8. All right, this is actually stating or giving us that this is supposedly, this is what is thought to be his mean, his actual population mean, because it's just him, and his population standard deviation. Thought to be population mean. His dad, Frank, thought that Jeffrey could swim the freestyle faster if he gave him goggles. So here we're kind of introducing an extra detail. We're introducing a new technique. And this is something that hypothesis testing can be used for too. I put forth this thought where I go, if I change this, will that increase my average? Will that decrease my average? I can make that alternative hypothesis with my new prediction and then collect more sample afterwards to test if my hypothesis proved to actually decrease the average or increase the average. So that's what's happening here. We have what is thought to be his original average, and his dad, Frank, thinks that he could be faster than average. Essentially, he thinks that his average could be less than 16.43. That's with the goggles. He thinks he'll be, not Googles, goggles. He thinks he'll be faster, or the average will be less than 16.43. That null hypothesis is that it's equal to 16.43. And that's because we were told, hey, this is his average. But then we go, oh, but I think, or Frank thinks, it could be less than that with this new addition. The type of test here, we're doing a mean, single population mean, and we know sigma. So this is our normal distribution for a single population mean. And it's a z-test even more specifically because we know sigma. We know what sigma is here. All right, let's list the information that we're given as far as the sample is concerned. He buys him the goggles and he times 15 of Jeffrey's races. That's my N. For the 15 swims, so this comes like this is about those 15 swims, we have a mean time of 16 seconds. That's our X bar. That's the average just for the sample mean of 16 seconds. Conduct a hypothesis test using a level of significance of alpha being 0.05. 5% level of significance or 95% confidence level, all right? Those are hand in hand, synonymous statements. All right, let's go to that online calculator and fill in the pieces that we know. Sigma is known. We want to check that sigma is known. That sigma value was 0.8. All right, the X bar was 16. We calculated 15 of the races, so my N is 15. And then again, these two values are from the alternative hypothesis. All right, so please make sure you're writing these into your notes so that later you can kind of compare as you do your own work, as you do your own homework. All right, so we are putting in 16.43 because that's what he compared his average to. And our alternative is that we think it's less than, mu is less than 16.43. All right, click calculate. This is my z-score, and this is my p-value. I'm going to round both to 4 decimal places. Your homework online asks for these values. So make sure that you see, hey, these are where they're coming from. This is called a test statistic, that z-score. Test statistic. it was that Z value. Sorry, my cat. I hope that's not very loud. He's gonna, oh no, bloody. Sorry about that. Negative 2.0817. And that p-value was 0.0187. 0.0187. Cool. So that's what we get from that online calculator. Now we have to make our decision and our conclusion. The decision comes from comparing the p-value, 0.0187, to the alpha value, 0.05. And I write it this way just so that the numbers are next to each other and then we remember which one's which. You don't have to write it exactly like this, all right? But I like to put them next to each other because I like to show place value by place value. That's 1 past the decimal, we're tied. All right, 2 past the decimal, it's clear that alpha is bigger. 5 is bigger than 1. So alpha is bigger than p. Our rhymes, however, are involving p. So we think, is p high or is p low? P is the smaller number here. P is low. All right. And if the p is low, what was our rhyme? The null must go. My decision is that I reject H naught. I reject the null hypothesis. And if I reject the null hypothesis, that means that the alternative HA is true. This is the ideal situation. This is the situation where we have sufficient evidence. All right, so for a conclusion, I'm actually even going to add in a little more. So before I kind of gave you like a general where we could underline and fill in, there's one more piece I want you to add to the beginning, and that's what level of significance you ran the test at. Because if I ran this at a 1% level of significance, actually it would still be the same result. No, if I ran it at a 1% level of significance, P would be higher than alpha, 0.0100. All right, so your conclusion can be changed depending on the level of significance you run it at. So it's important when you note that to state what you ran the test at. Here we ran it at the 5% level of significance. Sorry, I'm gonna get him before he gets up behind the computer again. At the 5% level of significance, at the 5% level of significance, we conclude there is sufficient evidence, right? We had a solid conclusion. There is sufficient evidence. And now we state what the alternative was. That with goggles, Jeffrey's average time is less than 16.43. That with goggles, Jeffrey's, how did we spell Jeffrey? Jeffrey's average swim time is less than 16.43 seconds. Again, the kind of fill in the blanks here are the what percent level of significance at the blank percent level of significance. We conclude there is, here we successfully rejected H naught, so it was sufficient evidence to support, and then whatever the alternative hypothesis was is what goes into that last chunk of blanks. All right, hopefully you're getting the hang of it. We've got 2 more examples to go through.